Good evening. My name is Rohit Bhargava. I'm a researcher in the Beckman Institute, a professor of bioengineering, and the founding director of our cancer center on campus. Now, if you're wondering what's an engineer doing in a cancer center, that's a really good question. And today I'll try to explain what this is all about. So I grew up in the city of Jaipur in India, a city known for its architecture. My father's an architect, and I grew up actually helping him print blueprints of plans. I suppose I built a love for building things back then. My own personal plan was actually to play soccer, or as we called it in India, football, and I was one of the youngest people to play soccer for our school. But an injury slowed me down, and instead what I did was develop a love for speed on motorcycles. So it was my first exposure to realizing that technology can truly transform lives. In India, in high school, we all take a common exam if we want to enter engineering or architecture school. I placed 4th in India in the architecture exam, much to my father's delight, and following the logic of a 17-year-old, decided not to pursue architecture, but pursue chemical engineering instead. It was fascinating to understand how molecules behave and how molecules integrate into our lives. It became very clear to me as an undergraduate that the world really is molecular. So when I came to the United States to do a doctoral thesis, in my thesis we built a microscope that didn't measure the shape or color of objects, but actually measured the chemistry that we were looking at. This field is now called chemical imaging, and it's sort of analogous to optical imaging. So I took my chemical imaging talents and went to the National Institutes of Health. At that time, that was a fairly rare move for an engineer to go to a health campus. And my boss explained it this way: we have 20,000 biologists on campus and very few engineers. So I applied chemical imaging to cancer at the National Institutes of Health and started wondering what other engineering things can be applied to cancer to make similar advances. And more importantly, where could we do this? So you can imagine my joy when in 2004, approximately 2005, I learned that the University of Illinois had formed a new department of bioengineering. Within a week of learning that, I applied. Within 3 months of applying, I accepted the job offer to be the first external hire in our new department of bioengineering at that time. I came to Illinois because this place seemed like it didn't have any boundaries. This is really important because we're up against something that has no boundaries. Cancer does not respect who you are, what your economic status is, what your age is. It strikes without warning. It is something truly different in the medical world. Please raise your hand if you know somebody who has encountered cancer. As I thought, not a single person do we know that has not encountered cancer in their friend circle. About 40% of people will be diagnosed with cancer in the United States. Now raise your hand if you think we're treating cancer in the best way possible. I thought so. Not one of us. Yet, what is the path forward? What is a better way? To find an answer, actually all we need to do is look around us. Illinois engineering and Illinois technology has transformed the world in many different ways. And I came to this realization once the department had become somewhat stable in its 5 years. So in my year 6, I started thinking, how could we take what was around us and apply it to cancer? So in 2010, we started what we called then the Cancer Community at Illinois. It was a group of us coming together with no blueprint and no architect. 10 years later today, we are the Cancer Center at Illinois. We're perhaps the largest, most well-organized research group on campus. Our mission is to take and basic science and bring them to bear on cancer across the spectrum, across the lifespan. Our vision is that we will be the leading place to do this in the world. If you think of technology in cancer, you should think of Illinois. The reason we think that is really important is technology can make cancer care more humane. Technology can provide physicians the tools so that we don't have to guess what therapy to give. It can provide patients the tools so we don't have to wait to get the therapy that we need. It can provide researchers the tools so we can accelerate our search for cures. But technology also has another very important role. Technology can make a standard of healthcare accessible to all that is not possible today, regardless of your socioeconomic status. So we think this is an idea worth. But how does it actually work? So here are some examples from my own research. On the left-hand side, you see the standard way in which we diagnose cancer. We take a piece of tissue, put some dyes on it, and a pathologist looks under the microscope and tries to find out what this might look like. It takes a few days to get the first opinion, might take a few weeks to get the next opinion. What we're trying to do is build a system that's on the right that takes the chemical image of cancer and paints it into different colors. Here, dark blue are the cancer cells of concern. So right away, in a matter of minutes, you can try and see what the tissue looks like. The traditional method of doing this is on the left, something that is expensive, subjective, and you need the resources to be available to you. What we are trying to do in our lab is on the right. Take the power of chemistry, take the power of artificial intelligence and computer diagnosis, and bring it together. Instead of 2 days, we can now do this in 30 minutes. It's not only artificial intelligence that we're focused on today, it's the biological intelligence of the fantastic students and faculty we have on this campus. So today we're combining artificial and biological intelligence to diagnose cancer better. Tomorrow we're going to use quantum computing to take the data we acquire and predict at an individual level how that cancer is going to behave. It's not only our investment in our humans, it's also our investment in our technology and our resources that make this progress possible. Here's another technology from my lab. This is a technology that we now call 3D printing or additive manufacturing. Every other approach that you see to additive manufacturing builds up a structure layer by layer. In my lab, we literally print in midair. So we can print structures in air and make whatever shape and form we would like to. So in your seats, you have a few examples from the lab. For example, there's an eye with a mesh structure inside. This is printed in air. Some of you, and I have these samples here if you want to take a look. This is a heart printed out of sugar and encased in a plastic. Since it's printed from sugar, we call it a sweetheart. So you can print things like this, but what good is this technology for medicine? What we think is going to happen in the future is we will be able to print organs. So imagine a physician who wants to treat a person. We take cells from the person, put it into our printer, actually print a replica of the disease, maybe of the tumor or the heart disease in this particular case, test our drugs on it, and take it back to the clinic so that we can get the requisite treatment correctly the first time and as fast as we can. So this kind of technology can only be done at Illinois. In engineering, our expertise in the basic sciences, and certainly the talents of our people. There are other examples of great science being done within the Cancer Center, whether it's visualizing tumors in the operating theater, or taking a drop of blood and figuring out if there is cancer in the body, or taking new compounds that we discover in our Department of Chemistry and moving them through our pets into humans quite rapidly. We're also very proud of our students. We've developed new programs to train our students across the spectrum from high school to the early faculty level. We've also invested in the Cancer Center and resources that bring the campus together. So for example, just a few months ago, we received about a $3.5 million grant from the NIH to build the first common cell and tissue culture facility on this campus. Of note, that application received a perfect score of 10, and it was the highest ranked application among 270 nationwide. The world is now taking notice of what we're doing at Illinois. We've spent 10 years building up this effort on campus. In 2018, we officially became an institute on campus. Last year, we applied to become the first technology-focused National Cancer Institute designated cancer center in the nation. When designated, we've begun the process, and when we are successful, we will be only the 8th non-clinical cancer center in the nation. We would also be the first new basic science cancer center in the nation in 35 years. So we're in the midst of something that only happens approximately once in a lifetime. We have great opportunity here. We're already collaborating with Carl locally, with OSF, with Mayo Clinic, and with UIC. But with the Discovery Partners Institute, this is really a way to bring our cancer research to the rest of the world. We invite people in through the DPI to take advantage of the science and people here, and the DPI is a conduit for us to transfer our technology to the rest of the world. I want to give you a couple of examples of how people are already adopting our model. The first example is Imperial College. They are building a new center at the convergence of engineering and cancer. For the last 6 months, once a month, their director calls me up and asks me how we did it, and they're going to follow that model. About 15 months ago, Trustee Cepeda and President Killeen went on a trip to India and opened a door for us. We're now working with the Cochin Cancer Center to establish another model that is quite similar to ours over there. This center will serve about 10 million people in the southern state of Kerala. So you can already see the impact of Illinois science happening quite across the world. Here at Illinois, we're quite proud of 150 years of impacting the world. We have a really unique opportunity now to really make us the hub of cancer technology and science that will be the future of tomorrow. This is an opportunity for us to include and enhance the 150 years of impact and innovation quite across the world. We can do that. We're poised. We have great leadership on campus. We have tremendous support. We have the resources, and we have the ideas to move this forward. Now we need to invest in it more and enhance our partnerships. Together, we can really make this happen. And how could we not? The world is really counting upon us to make this happen. If we come together, we can make fear from cancer a thing of the past. And I hope you will join me. If you would like, some of you have this, but we can have more. You'll join me in crushing cancer. Thank you very much.